All right, to kind of introduce exponential functions written as logarithms, let's kind of revisit exponential equations. An exponential equation is written in the standard form of y equals a times b to the power of x. An example of an exponential equation is like such, y equals 2 times 3 to the power of x. Let's first work on trying to find the inverse of this. Now for my advanced crew, we did a lesson on this. For my regular crew, we haven't. But what we do to find inverses, you flip the x and the y, if you remember. So essentially we have x equals 2 times 3 to the power of y. So literally just the x and the y switch spots. And then we need to solve the equation for y. So in this case, we're going to have to get the base by itself. So we'll divide everything by 2. So we have x divided by 2 equals 3 to the power of y. Now, before, what we would do is whatever this exponent was, we would take the root of that. So if it was a square, we'd take the square root. If it was a 3, we'd take the cube root. If it was a 4, we'd take the fourth root. Now, because it's a y, there's no such thing as a y-th root. So we can't solve this. We're done. There's nothing else we can do to find the inverse. At least so we think. And this is actually where the term logarithm comes into play. A logarithm is what we would do. We would have to essentially take the logarithm of both sides in order to continue solving this problem, which we're going to have an entire lesson on solving logarithms, so we're not going to focus on that right now. But this is why a logarithm was created, so we could solve an equation where we have an unknown variable as our exponent. So let's take a look at what logarithms are.